So welcome to everyone. Today we are going to speak about Epanet, the water supply system based on the software of Epanet. That's the third and last part of 3 days webinar. The first part we have seen 2 weeks ago, how to draw the network, simple analysis. The week after we have seen how to do the time analysis, the behavior changing over the time. And this time we are going to see how to develop a backdrop map that you can put behind Epanet so that you can draw directly on Epanet. And additionally, we are going to how to use qGis and Epanet. There are 3 presentations, and the reason behind is because we might have different approaches. The first one corresponds to the situation that you are on the field. You are asked to check a water system, and you have only a map on a paper map. And they tell you there is a network there, we did a network, please check if this network is fine. But you have no idea, you have no shapefile, you have no, let's say, electronic map. So the only thing that you have is the paper map. So what you have to do is, first of all, you have to scan this map. And I start the presentation. This process will only work if you have a scale bar on the map. If you don't have a scale bar, or you just have, let's say, the number like 1 to 5,000, it might not work because you don't know exactly how it is going to be scanned. But if you have a scale bar, it's clear how long is 1 centimeter based on the scale bar. So you don't have any shapefile, you don't have GIS, and but you want to use the map, and additionally you want to use Epanet with the auto length on. During the first 2 webinars, you have seen that we have worked with auto length off. It means that we had to give the length of each pipe. So we have to find out the length of the pipe and then manually add the length. If you put the auto length on, you draw the pipe, and then the length will automatically be estimated. But of course, the rest of the information, like elevation, like water demand, like pattern, you have to give it manually for each element. So what you have to do first, you take your map on the paper and you scan it. That's an example. And you open your map with any raster graphic editor, like Photoshop, Irfan View, whatever, MS Paint. You have this one, like you see in the picture. Next step would be that you must have the scale visible. If the scale is not visible on your scan, the system is not going to work. So once you have scanned your map, you just have to cut exactly your scale bar, like you can see in the screen. You cut it and you copy it. You select it first and you copy it. And then you try to draw a border using the scale bar. So you can see here we have 800 meters, 2 times the scale bar of 400 in this case. It might be 500, depends on the scale bar. So we have this length here, and the same process you do for the vertical, and you have this length. Now you know exactly that this square here, it is 500 meters vertical and 800 meters horizontal. Once it is done, you have to crop out exactly this square that you know the dimension. So you select it again and you crop it. So now you see you have exactly an image that has the dimension of 500 meters and 800 meters. This is actually a very mechanical and rudimental process. It's easy to do. And you save it on this format, EMF format, which is the best one for Epanet. Once it is saved, you open Epanet, you go on View here, you go on Map Dimension, and you will get this mask. And here you click meters, and you put 0, which is this point here on the bottom left. And you put 800, 500, which is this point here. So now you give the dimension of your background on Epanet. You just click OK, and you introduce the map. And then you will see the map, its georeference on scale. Of course, you need to be sure that auto length is on. It must be on. If it is not on, depending on the version of your Epanet, you might click directly on the bottom left and click on auto length on, or you go to project setting and you click auto length on. Once this process is done, you have to verify that it is correctly done. How to do it? Just put 2 junctions on one junction here on 0 and one junction here on 400. Between the 2 junctions, put 1 pipe, and then in the property of the pipe, just check how long it is the pipe. If the pipe is around 400 meters, it means your background map has been properly inserted. If not, there is a mistake somewhere. So once it is properly inserted, then you just have to put the junction, and the pipe's length will automatically be estimated, and you don't have to found the dimension of the pipe. The rest is like workshop 1 and 2. So you have to give the elevation, you have to give the water demand, you have to give the pump curve, and the pattern. And then you can run the analysis. This process allows you to save time because you don't have to estimate or to calculate the length of the pipe. Of course, this is not a very precise process, but we have seen also that the length of the pipe, if it is not exactly correct, it doesn't really make a matter. If you have a mistake of 1 meter, even 2 meters, the friction losses of the pipe doesn't change too much. The elevation is more important than the length of the pipe. But the system is very easy, very quick, if you don't have other option to do it. I think it was very short, very quick. If there is any question, please ask. Otherwise, I will go to the next presentation that shows how to do a backdrop map when you have the shapefile. I go away here and I open the next one, which is presentation 3B. Okay, this one. Situation is different. We have a system, and we have as well our coordinate in our shapefile. But we are not going to use qGis. We are going to use global mapper. But of course, this shapefile can be used as well for qGis, for ArcGIS, for AutoCAD, whatever. So again, we open, the idea is that we insert in our Epanet our backdrop map with auto length on. And the idea is that the length of the pipe is automatically estimated. What you do first, you need to open your global mapper and put global mapper on the right projection, metric projection, like you have seen already. Metric projection, it's important also for AutoCAD, if you do it in AutoCAD. Of course, you need the shapefile of your spring, your junction, your pipe, your tank, settlement, and this you need in order to reproduce your situation on your global mapper. This is now, again, the same situation here where I live in global mapper. So you can change the color, you can do it nice, because this will be later your background map. It's like that, you do the nice map. Okay, again, I say again, the projection must be metric. And at this point, you go on view and you click on property. And you will get this information, all the information about this map. And you see here, you get the coordinate of all the 4 corners. This is very important. And it has to be metric, because this has to be metric coordinate. You copy this information, clicking on copy to clipboard, and you paste it in any text editor. Can be Word, can be text, whatever. You copy it, you paste it on it. Now at this point, you open, at this point, you make a picture of your map. You go to File, Capture Screen Content to Image. Can you hear me?
I lost your voice for a second, but now it's okay.
Yeah. It's fine. We can hear you.
Okay, fine. Everything is fine so far? Okay, so go back. We have to make a picture of this map. With Global Mapper, it's very easy. You go on File, Capture Screen Contents, and then you get this mask. Click on EPG, and OK. Once done, you save it somewhere, of course. And then you go to Epanet. You go on View, Dimension. And here you have again the same mask. You click on Meter. And now you open your text file. And you put those numbers that you have saved before, the coordinates of the corner. You put it here on this mask, like you can see on the arrow. So you give the coordinates of the corner, and automatically Epanet will include it, and you click OK. Doing like that, the background, let's say it is geo-referenced, just matter to insert your background map on View, Backdrop, Load. You take the picture that you have previously saved with a global mapper, and you will have this situation. Again, you have to be sure that auto length is on. If it is not on, do it. Go on Projects and Settings and put auto length on, and then check that in the same way like before, that everything went fine. So you put just 2 junctions on the scale bar, one here and one here. You put 1 pipe in between, and then you check the length of the pipe. You see here we have over 350 meters, we have only 17 centimeter mistake, which is fine for our purpose. So again, we have our backdrop map installed and georeferenced and in scale. At this point, we just have to put our junction, the tanks, the reservoir, the pumps, and we give the information like we have seen previously, and everything is going to be fine. So you save time. That's again a very easy way to do it. Okay. If there is question, please go ahead. Now I will show you the last part, which is a plugin of QuantumGIS. This actually, it is much more complicated, and I understood that it is not finished yet. Mr. Stefan Macke is the German guy who is actually drawing or developing Epanet. He tried to do this plugin, but I went through. I really spent a lot of hours understanding how it works. But finally, I understood that this plugin of QuantumGIS is not finished yet, and it can make only situation analysis or simple analysis. It cannot make time analysis, and additionally, it cannot include a pump because you cannot put the pattern. But what it does, which is good, it gives the length of the pipe automatically, and additionally, it gives the elevation of the junction automatically based on the digital elevation model. So let's start with this presentation. Okay, so the objective of this presentation is to understand how this plugin called qWater works. First, you open, like usually, your QuantumGIS software. QuantumGIS, for those who doesn't know, it's a GIS software, open source and free. So you can install it and you don't have to pay anything. You don't have to use any crack, which is finally good. And the first thing that you have to do always put the right projection. Again, for Switzerland, in case of our example, is 32 north, but for Syria would be 37 north. If you don't know how to put the projection and why you have to put the projection, here again the links of one tutorial that explain you what is the projection and why we need to put the right projection. Those links are going to be as well included in the YouTube channel on the notes below the movie or the clip. So once you have opened QuantumGIS, you have first to install the plugin. Probably you don't have it at the very beginning, so you go to Plugins, Manage and Install Plugins. Under the search option, just write qWater, and you will have this one, qWater, and just click Install. If you have a recent version of QuantumGIS, there shouldn't be any problem. Once this plugin is installed, a new icons will appear. So those are the icons that are going to be displayed on your QuantumGIS. If they don't appear, go on View Icons and just display the icons of qWater. Now, like we have done before with Global Mapper, just display on your QuantumGIS the situation. You know, with QuantumGIS, it's easy. You can make it nice. You can put many icons. I did it like that. That's my village, one where I live, not currently, but usually. And I put my very simple network. We have our borehole here. We have the pipes, the tank higher, and it goes down by gravity. I put all these layers, which are metric projection, in one group. I call this group basic map. If you don't know how to make a group, just select all the layers, right click on it, and make a group, like AutoCAD actually. Then you see those layers do not include any information. It's just a display of the pipes. There is just the name of the pipe, nothing else. There is no length, no elevation, nothing at all. Very simple shapefile. If you want to see what those shapefile contains, just click, go back on the layer, and then on this icon, open attribute or F6, and then you will see the content of your layer. You see I have the info, the name of the item, and that's it, and all, nothing else. Now we have to find the digital elevation model. qGis doesn't have a way to do it automatically, but global mapper it has. So we go back on our global mapper, we display again our area, we click on this icon here, the world, and here we click on, SRTM worldwide elevation data. This is a free available elevation model that can be for free downloaded. Of course, you need internet. It's not a very precise elevation model, but it is something better than nothing. Of course, if you would have a digital elevation model done by drone or by the total station, it would be much, much better. So you download the digital elevation model, SRTM, and connect, and you get this weird picture. Don't worry about that. With this digital elevation model, you can make many types of terrain analysis, but it's not the topic of this presentation. Next step would be to export the digital elevation model for the use of qGis. So what you have to do, you deactivate all the layer except the digital elevation model, like you can see in the picture. Only SRTM model is activated. Then you go to File, you go to Export, and you go to Export Elevation Grid Format. And this mask will appear, and you select them, Digital Elevation Model. Once this is done, you have to give here the name of the layer that you are going to create. I put the name of them 10 centimeter because here I put my resolution 0.1 meter. This depends on you. You don't really increase on precision, but it looks better if you have a higher resolution. So you can put 1 meter, it would be fine. If you leave the standards, the default setting, it will not look very nice, but the quality and the precision will be the same, because finally what counts is the digital elevation model, not the resolution of your display. Of course, you work on meters and you click OK. Click as well the PER projection, so that this elevation model comes with the projection, which is metric, and you will not have trouble. Of course, if you select a high resolution, this process will take a long time. For example, this file for me with 10 centimeter resolution, it is 0.8, so 0.8 gigabyte. So a heavy file. If you put 1 meter, of course, it will be much less, and the downloading will be quicker. But fine, I leave it to you to decide which resolution you want. You save it wherever you want, and you continue. If you don't want to use Global Mapper because you don't have it or for any other reason, there is another way that you can find and download the digital elevation model. Exactly the same digital elevation model. It's actually a system which is based on internet and the web. You go on this page, Earth Explorer, you select your data, you choose SRTM, then you have to identify the area of interest, and you click on the result. Then you see, if you click on this icon here and this icon here, you will see the tile that you have identified, how big it is. This is now Switzerland. You see one tile is almost half of Switzerland, including part of Italy. So in this case, doing like that, you download much more than requested. But you can download it. And then finally, you just download it. You see, it's only 24 megabytes. and the job is done. So you have two ways to do it: with Global Mapper, which I prefer, or through the internet. Once you have downloaded your digital elevation model, whatever it is from Global Mapper or internet, it's time to open it in qGis. To open it, you go on Open Data Source, this icon. You check, of course, the location where you have previously downloaded the digital elevation model, and you add it. If the model is very heavy, like in my case, it will take some time to upload it, but it will work. But important is that here you choose a raster. It's not a vector, it's a raster. Raster is like a picture. So click raster and add, and then you will have this digital elevation model on your qGis. Here you see the difference. That's the digital elevation model that I have downloaded from Global Mapper, and this is the big one that I have downloaded from the internet. But finally, the result is the same, and we can check. You can see maybe this red line. Go next. If I do the profile of the Global Mapper digital elevation model and the profile of the digital elevation model through the internet, it is exactly the same. So the quality is the same, just the process is different. But how to check the profile? That's again a new plugin that you can find in qGis. This is not important for Epanet, but nice to know. It is called Profile Tool. You go to Plugin, Manage and Install Plugins. You search for Profile Tool. You install the plugin, and then you have the icon of the Profile Tool that you can find under Plugin. You will find the icon. You just select your pipe, for example, and below the profile will appear. This is important to have the profile of your pipe whenever you work with Epanet, because finally you need to know where you have your depression on your pipes and do high spot for your pipe. And now if you do it with Global Mapper or if you do it with qGis, it doesn't matter. Important is that for each pipe you check the profile, because in some cases, if there is a big change on the slope, you might have to insert a valve on that. Okay, this is optional for the profile. Okay, now we are in yes, you are in qGis. The digital elevation model doesn't look very nice, but you can change the visualization. Just click on the layer and change the color, change the whatever you want. With qGis, it's very easy to change the layout and the display of your items. We don't have to do it, but maybe next time we are going to speak about qGis a little bit. We are going to see some plugins and to see how to make a map and to play a little bit around with qGis. Okay, now it is time to work with our qWater plugin. So we have previously displayed our base map, and we have created the group of the base map. Everything is there. Now we have to we have as well inserted our digital elevation model, which is there. Per default, qGis shows you the highest elevation and the lowest elevation. And now we add a group. Just right click on the browser and add group. And we make a group called qWater. Here inside, we are going to insert all the shapefile that are going to be considered by the plugin qWater. And we are going to create 4 new layers. We are going to create a new layer, a point layer called junction. We are going to create a point layer called reservoir, we are going to create a line layer called pipe, and as well we are going to create a point layer called tanks. Pumps is not required because at this time the plugin cannot consider the pumps. So that's why it's not a perfect plugin, but it is what we have. So how to create a new layer in qGis? Just click on this icon, new shapefile layer, and save the layer somewhere, choose the type of layer, line, point, or shape, and create it. So you have seen now in this group, I have created 1, 2, 3, 4, 5. Okay, pumps is not necessary, but I've created 4 new layers: reservoir, point layer, tanks, pipes, and junction, which is in the group of qWater. And if you check the attribute of each layer, you see they are empty. There is nothing inside, just an empty layer. At this point, we have to copy the information that we have on our base map into the layer of qWater. How you do? Let's copy, for example, the reservoir. You just click on reservoir, you click on editing, you copy it with you select it with Control A. Then you click on junction, you click on reservoir, you edit it, and you click Control V. So it means all the information that are in reservoir, qReservoir, have been copied and pasted in the layer called reservoir. The same for tank. You select the tank, you click on editing, Control A, you select the content of the tank, Control C, you copy the content of the tank, you go on tank, you select it, Control V, you insert or you paste the information of the tank. The same for the junction, you copy the junction from this tank, editing must be on, you select the junction of the qWater layers, editing must on, and Control V, you paste it. So finally, what you have done, you have just inserted the information from one group to the other. Copy and paste, very simple, but nothing else. There is no name, there is nothing. Just let's say it's not displayed, but what it is included here is just the location, the coordinate, which are not displayed. Done that, you have to open qWater plugin with this and put the setting. With this icon, you change the setting of the qWater plugin. Now you have to link the new selected layer, the new layer with the plugin. So here under junction, you choose the layer of junction. Under pipes, you link the layer of pipe. Under reservoir, you choose the layer of reservoir, pump not necessary, and under tanks, you choose the layer of the tanks. And of course here, it's important that you choose as well the friction formula that you want to use for your Epanet, like we have seen before. You click on select and you will have the option of the various formula. Then, this is under, where is my mouse? Under pipes here. You go on data. Here, you click calculate pipe length automatically. If you click on write backdrop map, it is not working. It makes a mistake. I don't know why. So you can try, but it didn't work for me, so I don't. But if you unclick it, it works. You can see here again, I've chosen the template, which is already there. Darcy and weisbach, liter per second. And then next point would be That's it. Okay, you can even give the information of the population, that if you have some other information. Again, you choose this one. Of course, in that case, I was choosing the formula of Darcy Weisbach. If you choose the formula of Darcy Weisbach, of course, then for the friction, you have to choose the right friction parameters. In that case, for plastic would be 0.015. Next point would be to make the model. You click on this item, and here you will get this kind of information, and it will tell you that many information are missing. Yes, it's true. Don't worry about that. Say yes. Now, finally, click as well, fill up the fields, this one. So previously, we have created on each layer the column for the missing information. And with this one, we fill the column with the missing information. It takes some time. And now, next point, of course, collect all the information that you need for your network. How many, the elevation of the pipe. No, this is not important, but how many liters per second is the demand, and type of, what else, the elevation of tank, the elevation of the reservoir. And now you check the layer have been automatically filled. For example, if you open the layer of the reservoir, you will see that automatically a column of the head has been created, column of pattern has been created, ID column, it was before, and DC ID column. And everything has been created like that. Fine, you don't have to do anything. Now you can automatically give the diameter of your pipes. Select, for example, all the pipes. You can do it with this icon, or you can do it on the map, as you wish. Then you just click here, diameter equal 75 millimeter, for example, and then update, and all the pipe will receive the diameter of 57 millimeter. Okay, you see now, okay, now it's 54 millimeter, no problem. Automatically inserted. The length is going to be automatically created by qGis. And now it's time to give the elevation of the junction. You click on this icon, 1, 2, 3, get at the elevation from raster. It will ask you from which raster. You select your digital elevation model that you have downloaded before. You click OK. And now all the junction received automatically the elevation. Of course, if your digital elevation model is not precise, the elevation is not precise. This we know. And of course, this is the elevation of the ground. So you might consider that the junction maybe it's a tap stand, so you should increase of 1 meter. Maybe you have to fill the elevated tank of a hospital, so increase this of several meters. Be aware that it takes the elevation of the digital elevation model, which is normally the terrain. Then you give automatically as well the rawness, the friction parameter. It is 0.0015. So you select, first you select everything, and then rawness equal 0.0015, update. Automatically all the pipes get this value. And now it is time to give the right name to the elements. For some reason, the plugin just give a random name, not random, but not a name that corresponds to your map. So that it's good maybe to give not here by the ID, but here the right name. So for example, the tank was called by me T1. So the junction were called junction 1, junction 2. So you have to give it manually, unless you are happy with the name that the qWater gives automatically. This again up to you. And additionally, for each junction, you give the demand based on your survey that you have done previously. Manually, you give the demand. That's it as well. For the reservoir, you need to give the head, because probably the reservoir, so the system doesn't give the head automatically for the reservoir, neither for the tank. So you have to give the head of the reservoir automatically. And next step would be to eliminate the column ID. If you leave the column of the ID, the system will not work. So what to do? In qGis, again, you open the attribute of each shape. This mask will appear. Then you just click on the editing icon. This icon will show you delete column. You click on that icon and you just select the column that you want to delete and you click OK. So doing like that, you delete all the ID column, which are not understood by Epanet. Once it's done, maybe it's good to check again the system, to fill it again, and then you can run the simulation. Like you see, I didn't put the pump and I didn't put any pattern because this plugin do not yet accept those pattern. So you run it, and if you are lucky, everything is fine. If you are not lucky, there might be some problem. Check what type of problem it is. If the problem is because there is no pressure, don't worry about that. Because of course, we don't have pressure enough. We don't have any pump. The system is not good, is not complete. Don't really take too much time for this warning. What you can do, you can load the default style. Doing like that, you will have the default style. You see the pressure everywhere, so you can have a first look on the pressure, on the friction losses on the pipe, on the speed of the pipe. But even the speed of the pipe is not that much important because we don't have any pattern. So we know that with the pattern, the speeds of in the pipe will change. But fine, if you don't have any warning, even better. Okay, this is done. Now, what we have to do, we have to click on that icon, on 1, 2, 3 icon, is it? Yes. Write Epanet enp file. This icon will just export your Epanet file that you can after import into Epanet. Of course, this icon misses the pumps, the pump curve and everything. It's just a simple analysis without pump. And then you go on Epanet, you open Epanet, you go to File, Import, Network. You just click on the file that you just have created and you type open. And if you are lucky, you have all the pipes with on the right length, all the junction with the right elevation, but you need to add the pump and you need to add the pattern. And that's it. That's it. It's rather complicated. It takes, maybe it is not really useful if your network is very small, but it might be useful for a very big network because this helps you to get all the elevation automatically. So in my opinion, this module is qWater, not Epanet, a mistake, sorry. qWater is not that good yet, but still it can be used, and most probably in the future This module is going to be elaborated, so you know already, you have the basis already, and maybe in the future it will work much better, including pattern and time analysis.